Mercury has a large metallic core with a radius of about 1,289 miles, that is equal to 2,074 kilometers. Mercury spins slowly on its axis and completes one rotation every 59 Earth days. Its obliquity to orbit is of 0.01 IE. The equator of Mercury nearly coincides with the orbital plane of the planet. Mercury's diameter is 3,030 miles, that is equal to 4,878 kilometers. Venus is known as the brother of the Earth due to the similar size. It's 92 million kilometers away from Earth. Venus has a slow rotation period and in the opposite direction. It takes approximately 243 Earth days to complete one full rotation. Venus has an equatorial diameter of 12,104 kilometers. The Earth consists of several layers: the crust where we live, beneath the crust the mantle, below the mantle the outer core, and the innermost layer, which is the inner core. Earth rotation period, also known as its day, is approximately 24 hours. The tilt is approximately 23.5 degrees relative to its orbital plane around the Sun. Earth's translation period is about 365.25 days, which is why we have leap years every 4 years to account for the extra quarter day. The equatorial diameter of Earth is approximately 12,742 kilometers.
The distance between Jupiter and Mars is of 536 kilometers. Mars. The internal structure of Mars consists of crust, mantle, and core. Its rotation period is of 24.6 hours and 39 minutes, and the axial tilt is of approximately 25.2 degrees. Its translation period is of 687 Earth days, and its equatorial diameter is of 6,792 kilometers. Jupiter is a giant gas. Its internal structure is primarily composed of atmosphere, hydrogen, liquid metallic hydrogen, and core. It completes one full rotation in approximately 9.9 hours, and the axial tilt of Jupiter is approximately of 3.33 degrees. Also, its translation period is of 4,332 Earth days, and its equatorial diameter is of 139,822 kilometers.
Saturn is stunning and has a distinctive ring system. Saturn is 2 billion away from Uranus. It has a fast rotation of about 10 hours and 33 minutes. It's similar at Earth's axial tilt, approximately 26.73 degrees. Saturn has an average of orbital period of 29.5 Earth years. Saturn has an equatorial diameter of 120,000 kilometers.
Uranus is believed to have a relatively small rocky core at its center, composed of heavy elements such as rock and metal. Uranus takes approximately 17.24 hours to complete one full rotation on its axis. The axial tilt of Uranus is approximately 97.77 degrees. It takes approximately 30,685 days to make one lap around the Sun. The equatorial diameter of Uranus is approximately 51,118 kilometers. The distance between Uranus and Neptune is of 2,404,188,386 kilometers, which is equivalent of 24 centimeters in our model. Neptune has a relatively small and rocky core at its center. This core is composed of heavier elements such as rock and metal. The core is surrounded by a layer of water and other compounds. It takes approximately 16 hours and 6 minutes to complete one full rotation on its axis. Neptune's axial tilt is approximately 28.32 degrees. Neptune takes 60,190 days to make one lap around the Sun. The equatorial diameter of Neptune is approximately 49,244 kilometers.
Now I'm going to explain our representation of the moon phases. First we have the full moon, waxing crescent, first quarter, waxing gibbous, full moon, then the waning gibbous, third quarter, and waning crescent.
The seasons of the year are created due to the inclination of Earth's rotation axis and its orbit around the Sun. Due to the inclination of its axis at different times of the year, the Earth is in different positions along its orbit. For example, when a hemisphere of the Earth is inclined towards the Sun, the hemisphere experiences summer. When it's leaning away from the Sun, the hemisphere experiences winter. The spring equinox marks the beginning of spring in the hemisphere where neither the North Pole nor the South Pole are inclined towards the Sun. At this time, sunlight is distributed relatively evenly in both hemispheres, resulting in warmer temperatures and a gradual increase in the length of the days in the hemisphere where spring begins. The summer solstice marks the beginning of the summer in the hemisphere where the North Pole is inclined towards the sun. During the summer solstice, the North Pole reaches its peak of inclinations towards the sun, resulting in the longest day and the shortest night of the year in that hemisphere. The autumn equinox marks the beginning of autumn in the hemisphere where neither the North Pole nor the South Pole are inclined towards the sun. At this time, sunlight is distributed relatively evenly in both hemispheres, resulting in cooler temperatures and a gradual shortening of the duration of the days. The winter solstice marks the beginning of the winter in the hemisphere where the North Pole is inclined away from the sun. During the winter solstice, the North Pole reaches its peak of inclination away from the sun, resulting in the shortest day and the longest night of the year in the hemisphere. As a final note, let's remember that the combination of the inclination of the Earth axis and its orbit around the sun results in the different seasons in the northern and southern hemispheres. While one hemisphere experiences summer, the other experiences winter, and vice versa. The equinoxes, on the other hand, mark the intermediate changes towards spring and autumn, when both hemispheres receive similar amounts of sunlight.